Hi guys, hi. So I'm going to go through section A. I probably will do section B for tomorrow morning. It's just time. So let's kick through. So what I'll do is I'm going to make, like there's 30 questions. So I'm going to make 6 short videos. I'll do 5 questions and then end. So to make it sort of crisp. Okay, great. So let's start. So again, this is question 1. Joint costs. Now, we did a question on it. It doesn't come up often, but it's nothing. It's really arguing that you have made 2 products via the same process. So a process has sort of one process has taken place, and in the end, you came out with 3,000 units of A and 9,000 units of B. That's where they're really going here with this. So the argument here is that we know what we're able to sell these things for. We're selling it for £3 for A and £4 for B. But the question is, how do we apportion the costs? And it is quite reasonable to sort of say, well, we could apportion it based on units, but they actually tell us that we want you to apportion it based on market value. So really, the first question we really should sort of ask ourselves really then is, what is the market value? So if we look at the market value, if we're selling, this is all recorded, so I'm using sort of sheets everywhere. Anyway, what we have is you're selling £3 for A, so that's £3, and that's 3,000 units of A, which is 9,000, and you're selling £4 for B, and you are selling 9,000 units of B, and that's 36,000. So you have a total market value of 45,000. So the question is, what proportion? I mean, this is A and this is B. So the argument here is, this is our total cost. We could do a breakdown, but our total cost, what proportion, if you like, is A? So A would take, if you like, a 9,000 over 45,000. I'm just going to say 9 over 45. And B would take 36 over 45 times 20 times 20,000. And the question says for product B, which is what we're looking for, we're really looking at what is 36 over 45 times 20,000, and you will arrive at 16,000. Right? So that's the first one. So really it's a case of, it's really a case of some costs have gone in to making a product. They're joint costs, mixed costs, and then how do we sort of break them up? Remember, this is all revision. It's revision anyway. So a lot of these you typically either see a question in the textbook, but it's good that you're doing this so you can see some revision questions. Great. So that's the answer there, was D. Okay, great. Let's move on quickly. Great. So here we have a nice little question on throughput. We know with throughput we only consider material costs, so we have 50 minus 20, so we know what the throughput is, if you like, and it tells, so this is irrelevant, the conversion costs are irrelevant. It tells us that we need 8 minutes, if you like, to make an item. So if you like, you really could just sort of, it's asked per hour, so you know that you're making, I don't know, I mean, it's all up to you how you do your maths, but personally I just said, well, that's £30 for 8 minutes. Well, what is 1 minute? I will do 30 divided by 8, and then I will multiply that by 60, if you like. And because 60 minutes make an hour, and that will take me nicely to 225, if you like. Right. So the key point here really is that what is the return, and then I want the return per hour. It's £30 for every 8 minutes. So you're literally just upgrading. You're just trying to find what is the equivalent of 60 minutes. Great stuff. So that's that. That's question 2. Let's move on very quickly. Sometimes I'll use these as little teaching tools as well. So what I'm also going to do in this video quickly is I'll send you a little PowerPoint on EMAs. If you remember, I briefly talked about EMAs, and EMAs, I talked about flow cost accounting, I talked about input-output analysis, and I talked about activity-based budgeting. Now, throughput accounting is not used for EMAs. I think the last one actually was some element of life cycle costing, I think. Yes, but definitely not throughput. So really, flow costing, input output. So flow costing was the one where we separated things into materials, delivery, and clear up, if you like. Input was literally what goes in and what comes out, what percentage is going in and what comes out, whatever the difference is our wastage. And activity based is literally what activity based is, trying to look for the drivers of those costs. So the answer here is C. So I think it's good to just look at the textbook again and look at the page. Yes, just look at that page again. I believe that page is on, let me just quickly write it down. So again, page 57. Go to page 57. Just flip to page 57. This is still revision, and it's a good way to, page 57. Let's just look at that. 57 of your textbooks. Second. Yeah, sorry, more 63, page 63 to 65. Yeah, 63 to 65. Just have a quick breeze to 65 on EMAs. Quickly, just a good overview, and you'd revise that topic again. Okay, great. So now this is a great one. This is a good one for practice, right? So again, here, I could do this almost graphically. So this is about maximizing profit, and we know we maximize profit at the optimal point, right? And we know that's when MR is equal to MC. So the question here is, what is MR? And MR is a version of P, isn't it? We have the formulas at the front. So let's look at what they're telling us. They tell us that this is my price, this is my quantity, and they tell us that for every 10 pounds, if you like, they increase the price. For every 10 pounds, every time price goes up by 10, yes, the demand falls by 20. So we know the demand will fall from here to here every time the price goes up. So we know that we have a curve that looks like this. So we know that our gradient, if you like, is 10 divided by 20, right? The rise over the run, 10 over 20, and that's 0.5. So we get little clues, and we need to kind of do what we can. And then it says currently the company is selling 1,000 units at a price of £200 each. So we know we have an equation, P is equal to A minus BQ. We have that at the front. We know that's the equation of this curve, isn't it? Price and quantity. This is the relationship. We know what B is. B is 0.5, right? That's 0.5. We've just worked it out. We're told that they're selling 1,000 units. And we know what the price is at that point. So the question is, I want to find A because, if you like, that's the constant. This is A over here. And if I can find A, then I can plug things later on into this. So this is a staple, right? This is a staple idea. Good revision tool. So what do we have? We have, So we have 200 is equal to A minus half of this. That's 500. And so that means is equal to A minus 500, and therefore A must be equal to 200 plus 500, and therefore A must be 100. So now we know what A is. We know this is at this point, the price, we know definitely that's the highest price we have there, £700. At £700, you're selling nothing. So now that I know what that is, I'm just going to go, because this is getting a bit messy, I'm just going to go to a new page. So I know that A is equal to 700. I know that B is equal to 0.5. And I know that MR is equal to A minus 2 times BQ. So I know now that MR is equal to 700 minus 2 times 0.5Q. And therefore, I know that MR is equal to 700 minus Q, right? Because 2 times 0.5 is 1. So I kind of now have my MR formula, if you like. And I know that at maximum point, at optimal point, forgive me, the variable cost of 140 is equal to MR is equal to MC. So now I know that 140 MC is equal to MR at maximizing, when we maximize, and therefore at the optimal point, and therefore 140 is equal to 700 minus Q. So therefore, that means the optimal quantity, if you like, must be Q, must therefore be equal to 700 minus 140, which is equal to 560 units. So now I know what my optimal Q point is. So all I have to do is go back to, because the question says, what price should we sell this thing at optimal point? So now I go back to, let's open up my question sheet. Where we are, over here. And now I go back to my question sheet here. The question says, what's the selling price that will maximize profit? And I know P. So literally, I'm just really asking the question, well, P is equal to A minus BQ. So I know Q is now, so I know I'm looking for P. I know A is equal to 700. I know B is equal to 0.5. And I know Q is now equal to 560. So this is what I'm looking for. So so P is equal to 700 minus 0.5 times 560. Half of the just going to my calculator, 0.5 times 560 is 280. So P minus 280 is equal to 420. Right, great stuff. So let's go back to the question and take that off. And that takes us nicely to B. Cool, great. Let's move on quickly. I didn't want to spend this long. This is question 5. Great. So now again, be really careful. I'll keep saying it. It's just practice. Contribution is what I need. I need contribution, and then draw your little graph, and you're done. So these people sell. Anytime you're doing any of these sort of contribution variance things, just volume, whatever, just get the contribution. In mix and sales, details are to sell 1,000 units at a unit price of 200 to give a contribution to sales ratio of 30%. So they tell us what the unit price is. They tell us the selling price is 200, and they tell us the contribution is 30% of that. They tell us the contribution to sales ratio is 30%, right? C over S. So 30% of 200 is 60. So we know what contribution is. Contribution is 60. We know it. We've done it now. 30% times 200. Great. So now that we know that, it tells us that actual sales were 1,100. So basically, contribute 60, and we intend on selling 1,000 units. That's the plan. Then it tells us that you actual sales were this units, and you sell for that. Actual contribution, great, this is all good. But we're interested, this question is just asking about volume. Remember, volume literally just says, well, what's the volume change? The volume change was you moved from 1,000 to 1,100. That is a change of 100. At that contribution, remember, we're just looking at volume. And so therefore, it literally is, I mean, you sold more, that's good. 60 times 100, and that's 6,000. So that's a 6,000, oops, sorry, just 6,000. That's a 6 favorable. That's a 6,000 favorable contribution. Great stuff. I've spoken for too long. I usually try and keep each of the 5 questions under 10 minutes so that you're not too bored. Okay, great stuff. See you in the next 5.